Thank you again to everyone for joining today's webinar by IAC Acoustics. Today we're going to talk about IAC Acoustics Macrodyne Hardliner VRT rooms. First, a little bit about myself. My name is Andrew Polte. I'm with the IAC Acoustics as the NVH and Test Facility Sales Manager. I have over 16 years of experience in acoustic testing environments in a variety of companies. I worked with Honda as an engineer managing the testing facilities for transmissions, and also with Commercial Vehicle Group, or CVG. I was an NVH engineer in the research and development department. Now I'm with IAC Acoustics. I've been with the company since November of 2020. I focus on sales of testing facilities and product development, lots of other industrial projects as well. I come with a bachelor's degree in mechanical engineering from Ohio State and a Master of Engineering in Acoustics from Penn State University. So a little bit of background about IAC. We are part of the Catalyst Acoustics Group. It's a parent company that owns IAC and as well as a few other noise control and acoustic materials providers. Specifically on IAC's industrial team, we have Ted Marquis, who's my manager. He's the industrial sales manager. He's got more than 2 decades of an industry experience in industrial sales, specifically with in-plant noise control. Also, Darren Riley is our HVAC product sales manager, with a real focus on louvers, silencers, HVAC package system, sound control package systems, and then Kalina Winter is our industrial sales estimator. IAC Acoustics manufactures a variety of different facilities for noise control. Really, all of these facilities can kind of be summed up into 2 different categories. They're either anechoic, where the sound is absorbed by the room on the inside, or reflective, which is what we're going to talk about today. So sound is reflected on all the different surfaces of the room inside the enclosure. Both of these systems provide high sound transmission loss. So the IAC panel system, walls, ceilings, and floors have a high sound transmission loss to keep outside noise from coming in. But on the inside, the treatment really depends on what type of tests that you're looking to achieve. And today we're going to talk about specifically our VRT rooms, where we have more of a reflective surface where the sound power and sound energy is fairly uniform throughout the room when a sound source is played. An important design criteria in developing reverberation rooms to do sound power and sound pressure level measurements is the reverberation time, or reverb time. It commonly is designated as RT60. That's a fairly common designation you'll see in a lot of test standards or development specs from OEMs and other companies. The RT60 is the time that it takes for a sound source in a room to decay by 60 decibels once that sound source is turned off. So you have to assume that sound source is able to be turned off instantaneously, and then the time that it takes from a noise level of, for example, 100 dB to drop down to 40 dB, that would be the RT60 time. And that reverberation time really varies quite a lot depending on what type of environment you're in. You can think of being in an office or a vehicle where the reverberation time is fairly low, so you might have a very dead space where there's almost no echo in the room, and that reverb time drops off very quickly, as opposed to something like a gymnasium or a large indoor swimming pool facility. There's a lot of hard surfaces on the area and there's a lot of echo, so then the reverberation time is going to be very high because it takes a lot longer for that sound source to decay by 60 dB. Another important design criteria in reverberation rooms is the cutoff frequency. And I know there's a lot of math here, but really what these equations come down to is that the cutoff frequency really depends on the volume of the room and the reverberation time of the room in order to get what we call a diffuse field. And diffuse field is really just how sound is scattered about inside the room. If you have a perfectly diffuse field, then you have the same amount of sound energy at all frequencies in all areas of the room. So what we can do is design the cutoff frequency based on what we know is the cutoff frequency of the room. We can design the proper dimensions, the volume, and also the length, width, and height ratios that are required to meet that cutoff frequency. Here's an example of some diffusion panels that we've used for our Hardliner VRT rooms in the past. You can see that they have a different surface profile in each of these small squares inside the wooden box, the wooden boxes in the panels. So that allows sound to be reflected and scattered about the room in a very random and way. You don't have what we call standing waves. Standing waves are essentially amplified sound waves at certain frequencies, typically low frequencies, that can really negatively affect the acoustic measurements that are done in the room. Like I mentioned before, you want the reverberation room to be as diffuse and even as possible as far as frequency content. So IAC's Macrodyne Hardliner VRT rooms use a combination of diffuse panels, reflection, and absorption to achieve this. VRT stands for Variable Reverberation Time. The whole purpose of these rooms is to allow a lot of flexibility to adjust the RT60 or reverb time in that room. It's really important to be able to do this, especially for device manufacturers, electronic components, speaker manufacturers, manufacturers of conference phones, smartphones, anything where you're measuring the speech intelligibility of the room or even sound power of a device. Having the ability to be flexible in one space allows you to make just one chamber instead of having to have multiple facilities to measure one device. You can do it all in one space and really maximize and optimize the flexibility. There are a lot of standards that need these variable reverberation times, specifically related to ETSI or ETSI. There's a suite of communication standards that are very specific on what type of reverberation time is required to measure the device performance. And the variable reverberation times rooms or VRT rooms are really specifically designed to meet those standards. This is just explaining the cutoff frequency and with relationship to the volume of the space. This is a pretty common method or tool that's used. You can see that on the first line or the first row of this table, for a 125 hertz octave band or 100 hertz third octave band, you need at least a 200 cubic meter room in order for that cutoff frequency to apply. And as you move down in the table, the cutoff frequency gets higher, then the volume of the room required is smaller. So the larger the room, the lower the cutoff frequency will be for that room. With VRT rooms, we utilize our Moduline enclosure system, which has been around for many decades, and it's very reliable. Has, as I mentioned before, a very high level of sound transmission loss, and we can use the tools that we have for the walls, ceiling, and floor systems all in one airtight enclosure. We manufacture our own panels, doors, windows, floor panels, and steel detail, all manufactured in-house in the US, and we're able to provide a full turnkey system for the VRT rooms to allow you to maximize the efficiency of the room and really make any size that you might need with a variety of performances, colors, options. We can include doors of all kinds of sizes with our IAC noise lock and super noise lock door systems. Vibration isolation and floor panels are an option that are typically used for reverberation in VRT rooms as well. This turnkey approach really helps reduce the lead times and really improves the performance of the system. So I mentioned briefly our noise lock doors. We have a variety of different door constructions from STC 43 all the way up to STC 64, and that's just in a single door. So these STC performances are matched with our Moduline wall and ceiling panel system to give you a full turnkey approach to making these reverb rooms optimized, having as much sound transmission loss as possible while still maintaining it in a thin profile. Speech intelligibility is probably one of the more critical design factors in components for any sort of communication device. Lots of manufacturers, OEMs, and their suppliers are really getting pushed to improve performance for speech intelligibility, especially of small handheld devices. And that's really what these VRT rooms are designed to do, is to allow the user to do testing for not just measuring sound in a dB level, but also measuring sound quality, loudness, speech intelligibility, tonality, all these different variations and even customized sound quality metrics are really important for the end user. And with a variety of configurations available for these VRT rooms, it's very important to be able to have maximum flexibility. I mentioned there's a lot of design standards that are out there specifically for reverberation rooms, for these variable reverb time rooms. A few of the ones that I've seen most commonly are on the left here, ISO 3741, 3746, and then for the specifically for adjusting reverberation time, EG 202396 standard. That is something that I've seen a lot lately. These design quality standards are becoming more and more common nowadays. Most design manufacturers, designers for R&D and also for manufacturing systems are starting to utilize these standards a lot more because the communication device market is so competitive. Feel free to visit our website, iacacoustics.com. On the front page, you'll see a category called Test Facilities. You can hover over that with your mouse, scroll down to reverberation rooms, and you'll see that we just recently posted a new video and some literature on the VRT room specifically. So you can kind of see, the video really helps. You can kind of see and get an idea of how well and the amount of flexibility that's available for the VRT rooms. Well, again, I just want to say thank you to everyone for your time today. If you have any other questions, feel free to reach out to me, apolte@iacacoustics.com, or give me a call. I can hang around for a little bit to see if there's any questions that pop up. If anybody has anything, feel free to add it in that window or in the questions bar. Okay, somebody asked a really good question. What are the different types of panels that you use for the walls and ceiling? Yeah, so I showed, there's a few pictures of panels in here before. Really, there's 3 different types of panels that we can utilize. Oftentimes we just use 2. The first type in this beige color, these are just absorption panels. And depending on the frequency content and the amount of absorption you need, that will affect the thickness of these absorption panels and also the quantity. So these panels are really easy to remove and reinstall, and they're kind of designed to be optimized for quick removal and installation, because as you can imagine, and especially in larger reverberation rooms, there's going to be a lot of these panels that might need to be taken off and on a regular basis. So when we designed these rooms, we really wanted to optimize the ability to easily take them on and off and really help knock down the setup time. But the second type is reflection panels too. There are reflective panels available as well. They're not quite as common because typically these rooms have a very highly reflective surface on the base walls and ceiling themselves. But then the third type, what I was talking about earlier, are these diffusion panels. And their job really is not necessarily to reflect or absorb sound necessarily. What it does is it scatters the sound. So it takes sound waves of different frequencies and really helps them in different directions to improve that diffusion and reduce the standing waves in the room. Okay, I don't see any other questions on here, but again, feel free to reach out to me with any questions or comments. I'll be available anytime this week. But I wanted to say thank you everyone for your time and have a great day.